All right, so let's finish up. So this is part two, starting with number two on adding and subtracting polynomials. If you missed anything before that, you need to go back to video one. All right. So with number two, we're doing the same thing. We're adding polynomials, which is the same thing as combining like terms. That's all you're doing, combining like terms. All right. So I'm going to start with the highest exponent, 6x to the fourth, k to the fourth, and then negative 4k to the fourth, all right? Those are like terms, different signs, we're going to subtract them, so we get 2k to the fourth, all right? Maybe I should write that in yellow so that we can match with the underline, all right? So 2k to the fourth, all right? Now, next would be, we don't have any to the third power, so negative 10k to the second, and that does not have any like terms, so we're just going to bring that down. Negative 10k to the second. All right. Then we got 7k. That's a like term with negative 14k, so that gives us negative 7k. Different sign, subtract. All right. And then lastly, we have negative 14, and negative 14 does not have any like terms, so we're just going to bring that down. All right, and there's your answer. Okay. Now let's look at number three. Okay, we're subtracting, but there is a rule. Before you subtract, you have to change all of the signs after the subtraction symbol. Okay, so some people like to think of it as multiplying by negative 1. Okay, so this becomes negative r to the fourth and positive 5r to the third. Okay? All we did was change all of the signs, or take the opposite of their signs. Okay? So that's gone. We don't need that anymore. You could technically, let's bring all this down, 3r to the fourth, and then combine like terms. Okay? So let's start with the r to the fourths. So we have 3r to the fourth and negative r to the fourth. That becomes 2r to the fourth. And then we have 4r to the third and 5r to the third. That becomes 9r to the third. Okay? And that's your answer. You're done. Okay? If you need to rewind, you can. So the perimeter, all right, that's a common question with polynomials. Okay, it's just adding all the sides. So we have two of the sides given here, but we know that in a rectangle, right, the sides across from each other or opposite of each other are the same. So that means this is also 3x minus 6. Okay, so when I'm adding all the sides, I'm just combining like terms again. All right, so I have 2x plus 3x, that's 5x, plus 2x, that's 7x, plus 3x, that's 10x. So 10x, and then I'm going to add 4 and negative 6, that's negative 2, plus negative 4, positive 4, that's 2, plus 6, that is negative 4. So 10x minus 4. Okay? All right, so that's the perimeter. Let's do some multiplying now. Okay? So with multiplying, I think most of you are getting pretty good at this. For number one here, we're just going to distribute. All right, that's the easiest way to do it. Or you can do the area model of 1 by 2. So 4 times 2 is 8, and x times x is x squared. 4x times negative 7, that becomes negative 28x. Okay? And you're done. Can't combine like terms or anything. Now here, we have a binomial, that means 2 terms, times another binomial, another 2 terms. So we're going to use the area model. That is a 2 by 2, all right, area model. Okay? So this first one, 2x plus 7 is going to go on the side here. And then I'm going to put the 5x minus 3, I'll put that up top. All right? And we're just multiplying, okay? Kind of like a multiplication chart. So 5x times 2x becomes 10x squared. All right. Then negative 3 times 2x becomes negative 6x. All right. Then 5x times 7, that becomes 35x. And then negative 3 times 7, that becomes negative 21. Okay? Last thing you need to do is combine your like terms. The like terms are always going to be diagonal. Okay? So when we write our final answer, it's 10x squared. Okay? But we got to subtract these because 1 is negative, then 6 is negative. So that's going to be 29x minus 21. Okay? Now look at number 3 up here. Okay? So we're distributing, same thing, but we have a cubed right here. So negative x cubed times 6x, and we could write it, if you like writing that 1 right there, you can. Negative 6 times 1, that's negative 6. But x cubed times x gives us x to the 4th. Keep the base, add the exponents. Invisible 1 right here. Okay? And then negative x cubed times 2 gives us negative 2x cubed. All right? Now, almost done. We got one last problem here. Okay? So it says find the area of the rectangle. Area is length times width. All right? And we have the length and the width. All right? We're going to call the length 5 minus 2x, and then the width is 11 minus 4x. All right? So that means we're just going to multiply those two. Okay? Just like we did in problem number 2 over here. All right? We're going to multiply these the same way. All right? We can use the area model. And don't get scared because the constants are in the front. It's okay. We'll be fine. All right? So 5 minus 2x, and then 11 minus 4x. All right, so we get 55 right here, and then negative 22x, and then negative 4 times 5, negative 20x, and then negative 4x times negative 2x gives us positive 8x squared. All right, our like terms, guess what? They're still diagonal. Okay. So we can combine those, all right? And I'm going to write them in standard form. That means the highest exponent is going to come first. So when I write my answer, it's going to be 8x squared. When I combine these two, I get negative 42x. That's 20 plus 22. Both negative, so you got to add them. Plus 55. Okay? All right, so I went through almost the whole thing. If you have any questions, you can ask them in class. If you need to rewind to see something over again, you can. But study, 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 all right?